I'll start now. My name is Daniel LaPointe, and this is my University of Arizona MS and GIST capstone project presentation. It's titled Assessing Environmental Vulnerability to Anthropogenic Impacts Using GIS-Based Weighted Linear Combination Analysis in Sequoia National Park, California. The purpose of this project was to provide information to aid in management decisions. And to do that, I produced a map that shows environmental vulnerability to human activity. And what that identifies is the most vulnerable areas to human activity and also the least vulnerable areas to human activity. I did set some conditions on this project. One was to use only readily available public data, and another was to create a method that is very adaptable. Adaptable in terms of if updated data is found, it can be easily entered. If there are new variables that I want to insert into this method, it's pretty easy to do so. And also adaptable to other locations. Say they want to do this method that I used here in another national park, it'd be pretty easy to adapt. So my study area is Sequoia National Park. It's located in Central California. The Sierra Nevada mountain range runs directly through the park, which ends up causing a large range of elevations. In the western portion of the park, there are foothills that are just over 1,000 feet from sea level. And then in the eastern portion of the park, there's elevations that go up to around 14,000 feet, including the slope of Mount Whitney, which is the highest point in the continental United States. This range of elevation causes quite a bit of vegetation variation. The alpine zones generally have pretty sparse shrubs, and then all the way down to the foothills, it's more forested, and you have actually the giant sequoia groves there in the western portion of the park, which is the namesake of the park. Since the park was established in 1906, it has had near linear growth in attendance, all the way up to 2019, where they recorded over 1.2 million recreation visitors. And this presents a number of challenges for the park management team. Any increase in human activity really changes how the management team has to go about developing strategies. This is because humans are generally negatively impacting the environment and can be considered a stressor. So I'll introduce you a little bit to some of the data that I used, starting off with the Sequoia National Park boundary layer. Also used a digital elevation model, again showing around 1,000 to 14,000 feet. I used a recent land cover. I have rainfall data that I used. This is interpolated from a couple different stations and then averaged over 20 years to be a little bit more reliable. I looked at soil erosion in the form of soil erodibility here. Roads, location, as well as traffic. The same with trails, location, and traffic. And I also have points of interest, and I have a couple different types listed here. So the main method that I use to determine environmental sensitivity, which is one portion of my project, is suitability analysis. And this is essentially a method to determine the appropriateness of an area for a particular use based on some variables. But in this case, I used it to determine the level of environmental sensitivity for a particular area, which is Sequoia National Park, based on some variables. And those variables can be seen on the right there. There's 3 of them, each one of them is mapped out. The top is land cover, which for the purpose of this is essentially vegetation, though there is some urban areas and water that are taken into consideration. And this is important because different vegetations react differently, or are more sensitive to human impact. The middle variable or map there is solar radiance, which is essentially the amount of sunlight that is received on the area. Less sunlight generally results in more moisture in the soil and can change erosion a little bit. Which leads us to that final map there on the bottom, which is soil erosion. And that was calculated using the revised universal soil loss equation, which actually doesn't take into account moisture, which is why that solar radiance is important. but areas with greater erosion or potential for erosion generally are more sensitive to human impacts. The type of suitability analysis that I used is known as weighted linear combination. And what that does is it assigns weights to each variable. So each variable is organized into different classes representing the sensitivity to human activity. And by doing this and by making it into classes that I determined using a geometric interval, it allows them to be on a common scale. And so each variable can be compared and combined relatively easy. And so this shows them actually being combined. This is my environmental sensitivity map. It shows the sensitivity of each cell making up Sequoia National Park to an undefined but equal amount of human activity. And you can see here, generally in the western portion of the park, the environment is more sensitive to human activity. And in the eastern portion of the park, it's generally less sensitive. But for this project, I not only wanted to see how sensitive the environment would be to a potential human activity, I also wanted to look at how much human activity was there and how that would affect the park. So I used the cost distance tool in ArcGIS to model the likelihood of human presence. The first step to that is to generate an impedance map. The impedance map is a combination of both land cover and topography of the area. What this does is it models how difficult the each cell making up Sequoia National Park is to move through by setting an impedance. So for example, a forest is going to be harder to move through than a field, and therefore the forest has a higher impedance. Same is true for topography, where an area with a steep slope is harder to traverse than a flat ground area. So again, the steep slope would have a higher impedance value. The next step to this is to generate points of human activity. These are my points of interest shown earlier. They're campgrounds, lodges, visitor centers, as well as the roads and trails that make up Sequoia National Park. The tool, the cost distance tool, is then run to calculate how much it costs to travel away from each one of these features in every direction. So as you move further away from the feature, the cost increases, and the likelihood of a human being there is modeled as being less probable the greater the cost. This is because humans generally follow a path of least resistance, and therefore this is relatively effective at modeling the likelihood of human presence. And so that map looks like this, and you can see that there in the western portion of the park, there's a large block kind of northwest of high probability of human presence. And if we look at this map here, we see that's because the vast majority of the roads and the amenities in Sequoia National Park are found over in that western portion. If you look towards the eastern portion, you do see some high probability areas. That's mostly on trails, and then kind of on the eastern boundary in the center, that is Mount Whitney, which is a more popular hiking destination. We do kind of have this spot in the center east portion of the park that has low probability of human presence, and that's because it's relatively difficult to access. You have to hike pretty far in to get to there, and there's really no roads or amenities by that area. So to look at the environmental vulnerability to human activity, I combine these two maps, both the environmental sensitivity to human activity and the probability of human presence. So that map then looks like this. I developed, or 10 classes were developed to describe the vulnerability of the area. And if you look at the graph there on the left, you can see it's a pretty normal distribution for class area, with the middle vulnerability class making up the most area. And as you either go less vulnerable or more vulnerable, it's less overall area. So the results from this map show that there is about 300 acres that are most vulnerable, and they can be seen right here. It's a relatively small area when considering Sequoia National Park is over 400,000 acres. It is found in the northwestern portion of the park where there is a lot of amenities, roads, trails, and that sort of stuff. If you look at the top two most vulnerable classes, the area expands to about 10,000, almost 11,000 acres. Again, these are all around roads, trails, and points of interest. And you can see it highlighting the Mount Whitney area also to the east. Conversely, you can look at the least vulnerable areas, and that's kind of more towards the eastern portion of the park. It's 720 acres being the least vulnerable class, and about 10,000 acres in the top two most vulnerable classes. So again, the purpose of this research was to provide information to aid management in some of their decisions. And the information that I provided was areas that are vulnerable to human activity. By providing this information, it does allow park management to make more informed decisions when it comes to management strategies. And it was important to make this method relatively simple and adaptable. That way the management could take this technique and refine it however they wish. In 2017, Sequoia National Park, along with Kings Canyon National Park, which borders Sequoia to the north, published a document called the Resource Stewardship Strategy. What that document did is a detailed management objectives for Sequoia National Park. It's not necessarily actions that Sequoia National Park is going to take, but it identifies areas where they want to be more informed so they can make better management decisions. There's a total of 34 management objectives identified, and my project aligns pretty well with about 8 of them. An example of one of them that aligns well with is they wanted to assess resource vulnerability across the landscape to improve their understanding of characteristics driving vulnerability. So my project fits in well with that by looking at the human impact, that stressor, and saying, is that what's driving the environmental vulnerability, or is it something else, maybe climate change or another biological impact? Another point to make about my research is that it still requires validation. That likely would come in the form of in situ measurements and maybe some historical trend analysis. Because it hasn't been validated, I can't say for sure that this is accurate. But if I were to look at the in situ measurements, I could say, okay, this area has historically degraded over time and it has a high likelihood of human activity. So that would kind of confirm my research. Do we have any questions?